Assalamu alaikum. Well, last time we started the first exercise of your trigonometry based on definition. We solved some questions from the exercise. Question number 6 we did last time. You were given question number 5 for your homework, but I could get the solution of that only from one child. Remaining of you did not send me the solution of that. I would like all of you will send that solution of question number 5 so that I can understand how much you have understood. We shall now begin question number 7. In question number 7, we have cot of theta given equal to 7 by 8. Now, as usual, we'll draw the rough diagram, a right triangle, and then out of the 3 sides of the right triangle, measures of 2 sides will get indirectly from this given trigonometric ratio, cot, by using definition. Indirectly will get. The acute angle involved in this case is theta, and as you were told last time, this is a Greek representation of angle. Will be therefore representing one of the acute angles of the right triangle by theta. And with respect to that, we'll as usual decide the base and the perpendicular. Hypotenuse, as you know, is fixed. It is the side opposite to the right angle. Knowing the 2 sides, we'll apply Pythagoras theorem to find the third side. And then we will find those trigonometric ratios which are required as per the statement. So let us draw the right triangle. This is the right triangle. We'll name this right triangle as PQR. Any name of the vertices, any alphabet can be used, capital letter as name of the vertex. I have used P as the name of one vertex, Q as the name of second vertex, R as the name of third vertex. You could use A, B, C, D, E, F, X, Y, Z, whatever you would like. It is right angled at Q. Therefore, to us, PR will be the hypotenuse, side opposite to right angle. The 2 acute angles in this right triangle are R and P. One out of these you have to choose. And here for this question you have to put that as theta. Let us consider angle R. This is our angle, acute angle that we have chosen. We represented it by theta. Now with respect to theta, you have to decide the perpendicular and the base. The procedure has been already explained to you. The base is the adjacent side of the acute angle. QR here is the base. PQ therefore will be the perpendicular. Now knowing this, we'll use the definition of cot to get measures of 2 sides. We know cot is by definition cot theta. Cot is reciprocal of tan, and tan by definition is, you can get from that statement, some people have curly black hair to present beauty. Tan is perpendicular by base. Therefore, chord will be base by perpendicular. Base by perpendicular. Base and perpendicular we have already identified. In the figure, base is QR divided by perpendicular is PQ. So therefore, chord theta for this right triangle is QR by PQ. We already have chord theta 7 by 8. Now chord theta we got by definition QR by QR by PQ, and then we apply the Euclid's axiom. Chord theta will get eliminated. So what will we have? Therefore, QR by PQ will be equal to 7 by 8. 7 by 8. Which means QR will be 7 parts, PQ will be 8 parts. Last time you were told, we don't use here centimeter or meter because the unit is not mentioned there. We'll particularly therefore use the word units with these. 7 units and 8 units we'll say. Therefore, QR is equal to 7 units and PQ is equal to 8 units. Thus we got the lengths of two sides of this right triangle. Now comes the turn of finding third, and you know now we find the third side by applying Pythagoras theorem. Applying Pythagoras theorem, we know PR square, hypotenuse here is PR, hypotenuse square, PR square is equal to PQ square plus QR square. This is Pythagoras theorem. Now put in the values we know to get the measurement of third side. We know QR, we know PQ. Let us use their values. PR we would like to find. PR square will remain as it is equal to PQ is 8, so it will be square of 8, plus QR is 7, it will be square of 7. Simplifying, PR square will give us 64 plus 49. Add them. PR square will be equal to 113. 9 plus 4, 13. 1 carry, 6 plus 4 plus 1, 11. Therefore, PR will become equal to transpose square. It will be square root 113 units. Again here this square root cannot be removed because 113 is not a perfect square number. Last time we got 7 also, which was not a perfect square number. This time it is 113. Again it is not a perfect square number. So the root cannot be cancelled. Thus we got the measurement of third side also. After this, now we are asked to evaluate something. Two parts are there in the question. First part we have to evaluate 1 plus sine theta multiplied by 1 minus sine theta whole divided by 1 plus cos theta into 1 minus cos theta. Second part we have to find cot square theta. Let us first find these different trigonometric ratios which are required as per the statement, and then we'll find them one by one. We need sine theta, we need cos theta, we need cot theta. Cot theta is already given to us, so we need to find only sine theta and cos theta. So right, therefore sine theta is equal to. Now to find sine, you need to use the definition of sine. Definition of sine is given by that statement. First part of that, some people have sine is perpendicular by hypotenuse. Now their names we have already identified. Perpendicular is PQ divided by hypotenuse is PR. Use their values. PQ is PQ is 8 divided by PR is square root of 113. This is sine theta. Then cos theta also we need. It is base by hypotenuse by definition. Name of base and hypotenuse have already identified. QR being the base. Hypotenuse is again PR. And then use their values. The value of QR is 7 divided by PR is again square root of 113. This is the value of cos theta. Sin theta is 8 by square root 113. Cos theta is 7 by square root 113. Now having found this, let us now find part number 1. What is that? It is 1 plus sin theta multiplied by 1 minus sin theta whole divided by 1 plus cos theta multiplied by 1 minus cos theta. We have to find this. Now you may proceed in two ways here. To find this, you may proceed in two ways. Either put in the very first step the values of sin theta and cos theta and then simplify. Or you may first use the identity, algebraic identity you have. Both in numerator and denominator you can apply that algebraic identity. It is a plus b into a minus b, both in the numerator and denominator. And that is a square minus b square. Our a is here 1, our b is sin theta. Therefore a square will become 1 square minus b square will become sin theta square. Thus I shall proceed to use by using that identity here. A plus b into a minus b, a square minus b square. So I'll get 1 square, square of 1, a square minus b square will be square of sin theta. That will be sin square theta. Whole divided by. Similarly, it will be 1 square minus cos square theta. Now I would like to refer to one point here. When we write b square, it actually is sin theta ka whole square. Our b is sin theta, and then b square will therefore become sin theta ka whole square. This means square of whole sin theta, not sin alone, not theta alone. But as we have already read, this sin theta is not the product of sin and theta. We have already read it. It is the abbreviation, short form of sine of acute angle theta. Therefore, this square, when we say it belongs to whole thing, since it is not the product, had it been the product of sin and theta, or for that matter, if it would have been the product of sin and theta, then this square would belong to both sin as well as theta. Then we would write it as square of sine and square of theta. We would write it like this then, had it been the product of sine and theta. But it is not. It is the abbreviation. Therefore, we cannot put it on all the components of that product. It belongs to whole and is written as such. Now, conventionally, we write the square only on the trigonometric ratios. We write it as sine square theta. This is by convention. Means this square here means it is the square of the whole trigonometric ratio, including the trigonometric ratio and the angle. It is sine theta whole square. So remember this. And that I have used here. This is actually sine theta. B square will mean actually this, sine theta ka whole square. And by convention it means sine square theta. Likewise in the denominator it is cos square theta. Putting now their values, 1 square will remain as 1 minus the value of sine theta we have already found. It is 8 divided by square root of 113, and now the square of this whole divided by 1 minus cos square theta will be 7 by square root of 113 square of this. Simplifying further, square, you will perform square, multiply 8 by 8, multiply square root 113 by square root 113. This will therefore give us 1 minus 64. Square of 8 is 64. Divided by, when you square this square root of 113, here square and root will cancel. Concept you have already read. So what will we get? It will be 113. Whole divided by 1 minus 49 by 113. 7 square is 49, and here square will again cancel with root, 113 will be left. Then, simplifying further, you have to subtract the terms in the numerator as well as in the denominator, and for subtracting them we need their LCM. What will be the LCM? In the numerator, 113 is the LCM. 113 LCM, because one denominator of 1 is 1 itself, and LCM of 1 and 113 is 113. Now what will be the numerators? 113 minus 64 whole divided by. In the denominator also you have to find LCM. Again it is 113, and the numerator will be 113 minus 49. Simplifying further, when you subtract these, you'll get 49 by 113. In the denominator, when you subtract, you'll get 64 by 113. Subtraction. Then, further simplifying will involve writing reciprocal of the denominator. 49 by 113 is now multiplied by 113 by 64. From here, 113 will cancel with 113. And what is left? 49 by 64. This is the result of part number 1 of this question. Now, likewise, let us solve second part. In the second part, we need to find square of cot theta. Cot square theta you have to find. As just now explained, this again by convention we have written here on cot. Actually it is cot theta whole square. Thus what you need to do is to find the value, put the value of cot theta, which is given to be 7 by 8. Square of this. And the result will be then 49 by 64. This is the result of second part. Now, if you look at the results of the two parts of this question, both are same, 49 by 64, 49 by 64, which by comparison will mean that this cot square theta is equal to 1 plus sine theta into 1 minus sine theta whole divided by 1 plus cos theta into 1 minus cos theta. That was the solution of this question. Over to next question, question number 8. Question number 8. Now for this question number 8, what is given to us is 3 cot A. Well, this time the acute angle is represented by an English alphabet. A is written there. 3 cot A is equal to 4. And then on the basis of acute angle here, A is the acute angle. Can you choose the triangle which was already drawn there? We have named that triangle as PQR. Theta was the acute angle involved in that case, but this time it is not theta, it is A. Therefore, you may replace that theta by A there. That will be one way of drawing the diagram. You can name the triangle as PQR as it is in the figure with right angle at Q, and then instead of representing this acute angle by theta, you will have to represent it by A. Then inside that angle R, you can write A. Or, as we have been doing, we shall name the triangle by using the English alphabet involved in the question. As it is A, we can name the triangle as ABC therefore. And what is important is, A should be one of the acute angles. So you can name either A here or A here. This point cannot be A because it is a right angle. So what will we do? We will either name this vertex as B or C. Let us call this as A, this is then B, this is then C. Instead of B, you can also call this vertex as C, then this will be B. The triangle therefore we have used is ABC triangle. And in this right triangle, what is given to us now? 3 cot A is equal to 4. Well, one such question we had earlier also, question number 4, where 15 cot A was given equal to 8. It is 3 cot A equal to 4. I referred that time also to this question. While before we use the definition, you were told last time also, you have to isolate this trigonometric ratio. It is multiplied here by 3. Isolation of cot A will mean you have to transpose this 3 so that this cot A becomes in the form of a ratio here. When you transpose 3, it will become 4 by 3. Thus, isolation of trigonometric ratio here will give us cot A equal to 4 by 3. It is now in the form of ratio, 4 by 3. We have isolated it. 3 was multiplying here cot A, that 3 we transposed. This is the form in which we use the definition. And by definition, again we know, just now in the previous question also we did, earlier also we have discussed, cot is the reciprocal of tan. Now cot being the reciprocal of tan, we'll get definition of cot from the definition of tan. By definition, tan is to present beauty helps you to know the definition. Tan is perpendicular by base. What will be there for cot? It will be base by perpendicular, reciprocal. So write by definition, cot A is base by perpendicular. We have already identified base and perpendicular with respect to acute angle A. Base is AB, perpendicular is BC. Now base by perpendicular will therefore mean AB by BC. AB by BC is the definition. And then use Euclid's axiom. Cot A is 4 by 3, cot A is AB by BC. What will you get therefore? AB by BC is equal to 4 by 3. And this by comparison will give us AB is equal to 4 units, numerator equal to numerator, and BC is equal to 3 units. Denominator is equal to the denominator. We got the measures of two sides, like all previous questions. Now remains the measurement of third side, length of AC side, the hypotenuse here. And we will as usual find that by applying Pythagoras' theorem. Let us use and find. We know AC square is equal to AB square plus BC square. This is Pythagoras' theorem. Put the values. AC square is equal to 4 square, square of 4 plus square of 3. Simplifying further, AC square will give you 16 plus 9, that is 25. AC square is therefore 25. We'll transpose square. AC will be equal to square root of 25, and that will be 5 units. Length of third side we therefore got AC is 5 units. Now with these measures of the different sides, what we are asked to do, we are asked to check this time something. Check whether 1 minus tan square A whole divided by 1 plus tan square A is equal to cos square A minus sin square A or not. In the previous question we were not asked to find whether those are equal or not, but as we compared those at the end, we found those were equal. We found the value of first part separately, we found the value of second part separately, and then compared them. We found those are equal. Now likewise, here that part also is included. You have to check whether those are equal or not. So what will we do? We'll choose its left hand side, solve that separately. We'll choose its RHS, solve that separately. After solving the two sides separately, finally, as you were told in the last part, last question, we'll compare them, find whether their values are equal or not. Now to do all that, as in question number 7, we need some trigonometric ratios. This time we need tan A, we need cos A and sin A. Let us find first those before we proceed. Let us find therefore first sin A. What is by definition sine? Perpendicular by hypotenuse. I shall write P for perpendicular, H for hypotenuse. It is perpendicular by hypotenuse. Now we have already identified perpendicular with respect to acute angle A. Perpendicular is BC and hypotenuse is AC. Put their values. Value of BC is 3 divided by value of AC we have just now found 5. 3 by 5 is sin A. Then find cos A. By definition it is base by hypotenuse. We'll write B for base, H for hypotenuse. Base by hypotenuse by definition. And then the name of the base, from the figure you can see we have already identified AB is the base, AC is the hypotenuse. Use their values. AB is 4 divided by AC is 5. So 4 by 5. We also need tan. Let us find tan also. Tan A by definition is perpendicular by base. That means BC by AB. Values when we put, our BC is 3 divided by our AB is 4. So tan A is 3 by 4. Having found all these, let us consider now the left hand side of the result we have to prove, LHS. On the left hand side of that result that we have to check, we have 1 minus tan square A whole divided by 1 plus tan square A. Previously it was 1 minus sin square A divided by 1 minus cos square A. Now it is 1 minus tan square A whole divided by 1 plus tan square A. So the procedure of solving will again be same. What we'll do, we'll put the value of tan A, numerator as well as denominator. Then we'll combine them and get the result. So we'll have 1 minus 3 by 4. There is square of this 3 by 4 whole divided by 1 plus 3 by 4, and again we have square of 3 by 4. Thus it will give us, by using square, 1 minus 9 by 16 whole divided by 1 plus 9 by 16. Then LCM, to combine terms in the numerator and denominator, 16 is LCM in the numerator. We'll get 16 minus 9. Denominator also 16 is the LCM. We'll again get 16 plus 9. And when you simplify, you subtract them. 16 minus 9 is 7. It is therefore 7 by 16 whole divided by 25 by 16. Simplifying further, you need to write the reciprocal. It will be therefore 7 by 16 multiplied by 16 by 25. When you cancel 16 with 16, your result is 7 by 24. That is the value of LHS. Procedure was same as that of previous part. Now consider the second part of this. Cos square A minus sin square A. Cos square A minus sin square A. Now this time you have to use values of cos A and sin A. We have already found those. Cos A is 4 by 5. Sin A is 3 by 5. Use those. It will be 4 by 5 and then square of this. Minus for sin A 3 by 5. We have again square of this. Simplifying. We'll we'll get 16 by 25 minus 9 by 25. Squares of 4 by 5 and 3 by 5 we have found. Now to combine them, LCM will be 25. 16 minus 9, that is 7 by 25. The previous question was done only up to this stage. Now here you have to check whether those are equal or not. We find the results of both LHS and RHS. This is actually not the second part, it is the right hand side. RHS. LHS we got 7 by 25. Now RHS also we got 7 by 25. These are equal. So what will be the conclusion? Therefore, 1 minus tan square A whole divided by 1 plus tan square A is equal to cos square A minus sin square A. That completes the solution of this question. This was our question number 8. Now question number 9. That will be the last question for this day. Question number 9. Question number 9. According to the statement we have in triangle ABC, right angled at B, if tan A is 1 by root 3, tan A is given this time. This time name of the triangle also is given, unlike all the previous questions. Right angled at B. So will this triangle serve our purpose? Right angled at B, it is triangle ABC, right angled at B. So this will serve our purpose. The acute angle involved is again A. Tan A is given to us. So A is the acute angle, and I have marked that A as acute angle. So therefore same figure is sufficient. And with respect to that A, we have already decided base is AB, perpendicular is BC, AC is the hypotenuse opposite to right angle. Tan A is given equal to 1 by under root 3. We have to find the value of two parts are there. Let us first use the definition of tan to get lengths of two sides and then apply Pythagoras theorem to find the third side. Now by definition, tan is perpendicular by base. Tan A is perpendicular by base. I have written P for perpendicular, B for base. Tan is perpendicular by base. We have already identified BC is the perpendicular, AB is the base, so it is BC by AB. And then by comparing using Euclid's axiom, we get BC by AB is equal to 1 by root 3. Steps are same. We have discussed it in detail earlier. That gives us BC equal to 1 unit and AB equal to square root 3 units. Lengths of two sides we have got. Now how will you find third side? As usual by applying Pythagoras theorem. Apply and find. We know AC square is equal to AB square plus BC square. It is Pythagoras theorem. Use the values of known sides to find unknown one. AC square will then become equal to under root 3 square. AB is under root 3 plus 1 square. BC is 1. You will cancel square with root. AC square will be then equal to 3 plus 1. AC square will become equal to 4. We'll transpose square to get AC. AC is then square root 4, which is equal to 2 units. It's a perfect square. Square of 2. AC is therefore 2 units. We got the third side. And now, having found the third side, we now need for this question sine A, cos A, sine C and cos C. Let us first find sine A. Sine A by definition is some people have perpendicular by hypotenuse. Sine is perpendicular by hypotenuse. What is the name of perpendicular? It is BC divided by hypotenuse is AC. Put the value. BC is 1, AC is 2. So sine A is 1 by 2. Then cos A, base by hypotenuse. Name of base is AB. Hypotenuse is AC. Use their values. AB is under root 3 divided by AC is 2. Sine A cos A. Now next we need sine C also here. Acute angle has been changed. Now it is instead of AC. C you have to use as acute angle. Now with respect to C, your base and perpendicular will change now. With respect to C, your perpendicular will become base, your base will become perpendicular. So definition is same, perpendicular by hypotenuse. Sine is perpendicular by hypotenuse. Now the name of perpendicular will change because acute angle has changed. So what will happen? What was perpendicular earlier will now become base. What was base earlier will now become perpendicular. Therefore, with respect to C acute angle, AB will be the perpendicular divided by AC, hypotenuse will not change. We use their values. AB is under root 3 divided by AC is 2. Then cos C, base by hypotenuse. Base is now BC. Earlier BC was perpendicular, now it is base by AC. Use values. BC is 1, AC is 2. So cos C is 1 by 2. Having found these, let us now solve those two parts of the question. Part number 1, we have to find sine A into cos C plus cos A multiplied by sine C. How will you solve? Put the values. You have already found those values. Sine A is 1 by 2 multiplied by cos C is also 1 by 2, then plus cos A is under root 3 by 2 multiplied by sine C also is under root 3 by 2. This will become 1 by 4 plus this will be under root 3 square. Square and root will cancel, so it will become 3 divided by 4. 4 will be the LCM. To add these, 4 will be LCM. 1 plus 3, 4 by 4, 4 ones are 4. The result is 1 therefore. Similarly, second part, we have cos A into cos C. This time it is minus there. Minus sine A into sine C. Use their values also. Cos A is under root 3 by 2 multiplied by cos A is 1 by 2, then minus sine A is 1 by 2 into sine C is under root 3 by 2. When you simplify, you will get under root 3 by 4 minus under root 3 by 4. Both these will cancel. The result is therefore 0. With that, we will conclude the day.